Hello. In this seminar, we are going to look at perpendicular bisectors. Before we start on the seminar, I want you to go to your assignments. I want you to find the Module 6 pretest, and I want you to complete that to see what you know and give you a kind of idea of what we're going to learn. Also, if you go into the textbook, into the launch section of MT6, you can find the video explaining what we're going to be learning. The state standards, notice once again, we're going to prove theorems about lines and angles, and we're going to prove theorems about triangles. What we're going to concentrate on is making sense of problems, reason abstractly and quantitatively, and constructing viable arguments. The actual material we're going to be looking at is we're going to prove theorems and solve problems about perpendicular bisectors of a line segment. So in other words, we have to know what a perpendicular bisector is to do this. We're going to prove theorems and apply methods to solve design problems using the perpendicular bisectors of a triangle. The first thing, we've done bisectors before, and we've done perpendicular before. Now it's just putting it all together. So if I have this line segment, and I find the midpoint, and I construct a line that is perpendicular to this line, that makes this a perpendicular bisector. So for example, on this one, we'd say XM is your perpendicular bisector. Now, we know two things because of this. And I need to move the screen down so you can see. One is the perpendicular bisector theorem. And the perpendicular bisector theorem says, hey, if I have a perpendicular bisector, like in this DC, see how it's at a right angle and it goes through the middle. Any point on this perpendicular bisector is going to be the same distance from the endpoints. Doesn't matter where that point's at. I could have E down here, and E is the same distance from A and from B. And then we have the converse of the perpendicular bisector theorem, which says, hey, let me erase this first. If I have a point that is the same distance from either endpoint, then that point is on my perpendicular bisector. Notice these are theorems, which means we're going to prove them. That'll be 2 problems on your assignment. You'll have to prove why this is true on your assignment. So we're not going to do that in class today, but you're just going to prove the triangles are congruent, like we did in chapter 5. Now, if I take a look at example 1 here, notice G to E is our perpendicular bisector because it's at a right angle and it's the midpoint. So what does that tell me? That tells me my 2 segments, EF and HF, they're the same. Since they're the same, I can make an equation out of that, and we'll say 4a minus 15. And it's going on here with my pen. There we go. My pen is not working. There we go. Equals a plus 12. Now we're just going to solve that equation. So let's subtract a from both sides. At the same time, I want to get rid of that 15, so I'll add 15 to both sides. In this case, notice 4a minus a is 3a. 12 plus 15 is 27. You divide by 3, and a equals 9. Notice I don't want a. I want to know e to f. So e to f is 4a minus 15. So 4 times 9 minus 15, which will be 36 minus 15. Which would be, what, 21? And there's our answer. I think that's it for this page, but I'm going to scroll just to make sure. Yeah, we'll do the next one in the next video.